Sequent Microsystems designs and manufactures I/O cards for signal processing and automation. Our products fall into three categories. First, we have our general-purpose cards, which have as many features as physically possible in the available space. Next is our evolving family of modular programmable logic controllers, with more than 10 stackable cards with identical dimensions and connector placement, which can be mounted open frame or enclosed. And last but not least, we have essential accessories and Raspberry Pi replacement solutions for automation systems. 3 general-purpose hats cover systems for home, building and industrial automation. Slightly larger than Raspberry Pi, these cards cram as many I/Os as physically possible in the available space. All have pluggable connectors and hardware watchdogs and are stackable to 8 layers. The first card in this group is the home automation hat. It features 1 wire and RS-485 communication ports. 4 PWM open drain outputs are able to drive 24 volt and 4 amp DC loads, which can be used to control LED strings. 8 relays with normal open contacts can switch 24 volt and 3 amp AC or DC loads, and can be used to control sprinklers and heating and cooling systems. 8 optically isolated inputs can read proximity switches or contacts from your security system. 8 0 to 3 volts analog inputs can be used to read zone temperatures using 10K thermistors. 4 0 to 10 volt analog outputs can be used to drive light dimmers. A heavy-duty power connector can power the full stack, including Raspberry Pi, with 5 volts and up to 4 amps of power. The second in our group of general-purpose cards is the building automation hat. Stackable to 8 layers, this card has 8 universal inputs which can be individually selected by jumpers to read 1K or 10K thermistors, 0 to 10 volt analog inputs, or dry contact counters. A tactile push button can be used to set an output or to reset Raspberry Pi without a keyboard. An RS-485 port can interface with controllers using the Modbus protocol. 1 wire port can read up to 16 temperature measurement devices. 4 0 to 10 volt analog outputs can be used to drive light dimmers. 4 triac outputs can drive AC loads up to 1 amp and 24 volts. A 24 volts AC or DC standard transformer or power supply used in building automation can power the card, which supplies 5 volts and up to 2.5 amps to Raspberry Pi and other cards in the stack. A real-time clock with battery backup assures accurate timekeeping if the power goes down. Our third all-in-one card is the industrial automation hat. Stackable to 8 layers, this card has 4 analog inputs which can be individually selected to read 0 to 10 volts, or -10 to 10 volt signals. 4 optically isolated analog inputs can read 4 to 20 milliamp signals with 12-bit precision. A tactile push button can be used to set an output or to reset Raspberry Pi without a keyboard. 4 optically isolated digital inputs can read signal closures or counter events. 4 open drain PWM outputs can control variable loads up to 24 volts and 4 amps. Other features include RS-485 and 1-wire communication ports. 4 4 to 20 milliamp analog outputs with 14-bit precision and load detection. 4 0 to 10 volts 14-bit analog outputs. 24 volts DC power supply which can also supply 5 volts and up to 2.5 amps to Raspberry Pi and other cards in the stack. And finally, a real-time clock with battery backup for timekeeping concludes the rich set of features of the industrial automation card. The Sequent family of modular programmable logic controller cards has more than 10 members, and more cards will be released soon. All the cards in this family have the same dimensions, identical connector, and identical LED placement. Usually the inputs are placed on the left side, and the outputs on the right side. Exceptions are made for cards which have only inputs or only outputs. All cards have the RS-485 port located in the lower right bottom corner. The 5 or 24 volt power connector is located in the upper right corner, with the positive terminal on top. The power LED is the leftmost one in the string of 9 LEDs located on the bottom row. The next 8 LEDs show the status of inputs and outputs. Cards with more than 8 ports, usually 16, switch the LED banks between groups of 8 inputs or outputs. Between the LEDs and the 485 port is always a push button, which is connected to a Raspberry Pi GPIO pin. The Sequent programmable logic controller cards can be installed on an open-frame DIN rail, or housed in our modular enclosure, which can also be mounted on a DIN rail. The modular enclosure can be expanded to any number of cards, by adding one ring for each new card in the stack. The bottom ring houses the Raspberry Pi, and the set is terminated by a top plate. The analog inputs can read 0 to 10 volt and 4 to 20 milliamp signals, measure temperatures from RTD and thermocouple sensors, and read frequency and filling factor of PWM signals. The analog outputs generate 0 to 10 volt and 4 to 20 milliamp signals, and drive variable loads with up to 24 volt and 4 amp open drain pulse width modulation. The digital inputs read AC and DC signals from 0 to 240 volts, quadrature encoders, and count events up to 500 Hz. The digital outputs can drive DC loads up to 240 volts and 2 amps, or 24 volts and 8 amps. Can also drive AC loads up to 24 volts and 1 amp. Relays can switch loads up to 8 amps and 24 volts DC, and 40 amps and 240 volts AC. The cards can be accessed using command line, Python, Node-RED, or OpenPLC drivers. We believe the maximum number of I/Os which can be accessed using OpenPLC is far greater and cheaper than any other competitor. The numbers in the following table are cumulative, which means you can build a system with 96 analog I/Os, plus 192 digital I/Os, plus 64 relays. This is indeed a very large number of I/Os controlled with a Raspberry Pi, able to satisfy the most demanding applications.